Trig 9, we're going to be finding trig functions given different pieces of information. So the first one we're going to be doing is if you're given a point. All right, so let's say I give you the point -4, 3, and you want to find the 6 trig functions from this point. Well, in order to do this, because it's not on a unit circle, you have to draw the picture. So in this case, I'm going to draw the picture as -4, +3. That's the point, -4, 3. But when I find trig functions, I got to do it over a right triangle. So my right triangle is -4, +3, where the hypotenuse always connects. The hypotenuse always connects from the point to the origin. Always. Therefore, the 90-degree is created by the x and the y, and my angle is actually the kind of the reference portion from the hypotenuse or the terminal side to the nearest x-axis. It's always, always created this way. We always connect to the x-axis. That is the only version of our picture. We can have connect to the x in the second quadrant, connect to the x in the third quadrant, first quadrant, fourth quadrant. It's kind of like a bow tie. But always your alpha, your angle, is always the hypotenuse and the x. That is the only type of triangles that we can have and that we are allowed to create. All right, once I create my triangle, I can then use Pythagorean theorem to find the other side. And this one happens to be one that we should know, a 3, 4. Hopefully we know that that's a 5. But if not, you are welcome to do Pythagorean theorem. So leg squared plus leg squared equals the hypotenuse squared. 9 plus 16 is 25, so the square root of 25 is 5. So if it's not a gimme, then go ahead and use Pythagorean theorem to find it. Now I'm going to find my 6 trig functions from that x-axis and hypotenuse using the information given to me. This is not on a unit circle. I cannot use the whole this is cosine, this is sine. All right? It's not on a unit circle. That does not apply here. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. All right? Now the cousins are just the flips. So once I do the measures, all I have to do is reciprocate them, and I've got the other 3. Do your homework in this same fashion, meaning do sine, cosine, tangent, and then the cousins. Cosecant matches with sine, secant matches with cosine, cotangent matches with tangent. If you do it this way one time, writing everything out, then on problem number 2, if you were given another point, let's say the point is 5, -12. So in this case, you would get 5 squared, which is 25, 12 squared, which is 144. So 25 and 144 is 169 for 13. Then I don't have to write out sine, cosine, tangent if I do them always in the same order. I could just put sine, cosine, tangent, and then the cousin. As long as I do the first one all completely written out and then always follow its pattern, I'm okay. You don't have to keep writing them out over and over again. However, if there's only one of these problems, you got to write it all out. If there's multiple of the same type, then you get to kind of abbreviate it a bit. All right, the next part says you're going to be given a function, find the others. For example, you're going to be given the cosine of an angle is √7/3. You're always going to create a triangle. I'm going to assume it's positive or in quadrant 1 unless it tells me otherwise. If this says this is quadrant 4, then I would, make my adjustments that way. But if it's positive, I'm going to assume it's quadrant 1. So I'm going to make my quadrant 1 triangle. I don't need to put an axis on it. I should know how to make a quadrant 1 triangle. Quadrant 2, quadrant 4, quadrant 3. You should be able to make those without necessarily having to make the XY axis. However, go ahead and make it if you need to. By telling me the angle is cosine, I'm telling you adjacent over hypotenuse. So I'm going to make the triangle. Now I'm going to do Pythagorean theorem to find the missing side. So I get leg squared is 9 minus 7. So the leg is the square root of 2. Now find the other functions means sine of my angle, cosine of my angle was given, tangent of my angle. You always must simplify, so multiply out the radicals. Then the cousins, when I reciprocate, again, make sure I simplify. And cotangent. I could just flip this, so √7/√2 is √14/2. So whether you're given a point or given a function, either way you're going to create a triangle. You're going to do Pythagorean theorem to find the missing side, and they're going to use that triangle now with all sides to find the relationships of the functions. The last thing I need to talk about is a cofunction. A cofunction means the angles add up to 90 degrees. And our cofunctions are not the cousins. Sine is the cousin and cosecant. They are reciprocals of each other. Cofunctions are what you think they should be. For example, the sine of 40 degrees is the cosine of 50 degrees. Sine and cosine are cofunctions. Secant of 20 degrees is cosecant of 70 degrees. Secant and cosecant are cofunctions. And then tangent of 15 degrees is cotangent of 75 degrees. Tangent and cotangent are cousins. Now tangent and cotangent have to be cousins as well, but the other ones are not. And cofunctions just mean their angles match up to 90 degrees. All right, so that is trig 9.